Hello, hopefully this microphone's working. Okay, we've had a few little technical glitches, so frantic setup. I'm going to be doing a talk about live coding, and we'll get a little bit into what that is in a minute. So firstly, who am I? What do I do? My name's Neil. I'm an artist technologist from Oxford in the UK. I've worked up until recently for 10 years doing various things around web consultancy, working with the cultural sector, education, charities. But alongside that, I spent over 15 years making creative applications in Java, which is something we'll sort of get onto now. I do with various bits of open source Java technology. I lead development of Praxis Live, which is a hybrid visual IDE for live creative coding. Alongside that, and as part of that project, I stream bindings for Java, various audio libraries, and recently involved with the Apache NetBeans project and NetBeans Stream team. Praxis Live is built on top of the NetBeans IDE, and I assume we're all aware that Oracle have now donated NetBeans to the Apache Foundation. So the sort of creative stuff I do with Java, various forms of audiovisual performance, and making interactive spaces. So this is one of the first works I did for a museum. Breaking out. So this piece, interactive audiovisual piece, where a webcam was tracking movement within the space. It's built in the time when something called JMF existed, the Java Media Framework. It was quite a while ago. Then more recently, working with a video called Naomi Morris. Sorry about that. So this was a piece where we projection mapped onto a stone fireplace, and then as people walked into the room, cameras picked up their motion and faces appeared and followed them around the space. This was a projection onto a building in a public square, where we had two cameras, one on either side of the square, and two strangers could dance together in various scenes that were projected onto the building. And then at the other end of the scale, a piece that was made for a museum. This is a take on a very early projection device called a magic lantern, except that in this, there's a tiny little Intel compute stick, LED projector, and all the slides had RFID tags in them in order to trigger video playback. And then more recently, which is what I'm coming on to now, I've got more into doing live coding itself as a performance. So, live coding, what is it? As always, if there's a little bit of an issue in determining what something is, we should refer to Wikipedia. Citation required. So here we have live coding is a performing arts practice and a creativity technique centered around the writing of source code and the use of interactive programming in an improvised way. Live coding is often used to create sound and image-based digital media, as well as light systems, improvised dance, and poetry. But for me, what's kind of interesting around the live coding sphere is it brings together people who come from a computer science background and from a creative arts background. Computer scientists getting creative artists learning how to code, and learning from each other. And various forms of research happening. There's now been 2 international conferences on live coding. I had the joy of presenting Praxis Live, the recent conference in Hamilton, Canada, and there's another one in a couple of months in Mexico. Then alongside that, you have people who are performing all around the world doing various forms of live coding, including over the last few years a growing number of algo raves, where people live code visuals and audio for people to dance to in nightclubs. Some of the live coding tools you may have come across before. Very obvious one is Sonic Pi, which unsurprisingly you will find installed on the Raspberry Pi, although you can use it on other things. It's quite simple to get into as a live coding environment. You'll see here, it's based on Ruby, but it has this very simple system for play a note, sleep for a bit, play a note, sleep for a bit. It's very good for education. It's often used for teaching kids how to code, but it's also quite powerful in performance. Another environment, tidal cycles, by Alex McLean originally, anyway, who is also one of the people who came up with the idea of algo raves. Tidal cycles is used a lot for people performing live coding. It's a Haskell-based DSL for doing pattern manipulation. This is probably a slightly unfair representation of, it's not necessarily always that complicated. There are a simpler way in as well. An environment, you may have come across Andrew Sorensen talking about extempore. He talks about cyber-physical coding, real-time coding of real-time systems. Extempore differs to Sonic Pi or to tidal cycles, both of which use SuperCollider as a sound synthesis engine. Extempore actually has a system where you can code all the way down. So it has both a scheme language built in and a scheme syntaxed language called xtlang that codes through LLVM to basically do native coding. So this is something that actually interests me, the idea of making a recodable systems language, and particularly the idea of doing that in Java, personally. And there are many more. This is just a small list that I came across on one of the sites talking about live coding. A couple of things to note there. Overtone, again, uses SuperCollider as a synthesis engine, but is based around Clojure on the JVM. And then SuperCollider, which is kind of in bold, has a language all of its own, as well as being a synthesis engine for many of these systems. And going back to Wikipedia again, if you look at the live coding page, you'll say, not to be confused with interactive programming. And you go to the interactive programming page, it says, not to be confused with live coding. This is despite the fact that most of the examples on the interactive programming page are live coding. Something that's always interested me is this space in between those two seeming fields. And I think extempore is also an example of a system that is partly about interactive coding. Interactive programming is not necessarily that new. If you talk about influences on Java, one of them is Smalltalk. Now, Smalltalk has always allowed interactive programming, something we haven't really inherited. So a contemporary open source Smalltalk environment is the Faro IDE, which allows for completely live programming of almost anything. And there's a little bit of graphical live programming in Faro here. We'll come back to that in a second. So maybe one topic of this talk is make Java more Smalltalk. So on to Praxis Live. This is my own system based on NetBeans platform and the JVM in Java. Okay. Ooh, you can just about see yourselves. So, what do I mean by a hybrid visual system? Praxis Live is partly about visual programming. So we have a range of components that we can add into a graph. We can connect them together or disconnect them. And a palette full of other components that we can add in. So we can change maybe the rate of change. So various things we can change through the visual interface. But what differs in Praxis Live to other visual programming systems is any of these components are also Java code that we can rewrite at runtime. So this is the component that's drawing our text on screen. Maybe we will and we see immediately we save, we're re-injecting, and the video doesn't stop, and we have some changes. Here we have a filter which actually is doing absolutely nothing at the moment. So maybe we'll put, that feels more appropriate. So good morning, everyone. Hello, JDD. Okay, not the most exciting of visual examples, perhaps. So a second example here. Praxis Live can wrap pretty much any JVM library and allow you to work with it in a live coding fashion. So for visuals and 3D, it wraps an environment you may have heard of called processing, which gives us a simple way of interacting with OpenGL. So here we have a component that's creating a GLSL shader texture on our three-dimensional surface. If I look in the code here, you'll see that we just have a string for the fragment shader, which has an annotation that tells the environment that it's a GLSL fragment, which then allows me to edit it in the environment. So. And changing colors on our GLSL. So now, because where are you? Yes. Because video is also then just a texture brought into this environment, we can maybe stick you on there instead. We have a cylinder component here. You'll see there's some support for keyframe animation just here. And zoom that in a little bit. And then we can also start rewriting maybe what that is doing here. So we can start making some interesting three-dimensional shapes here. Live coders will often, well, one of the key things is actually about projecting code to the audience. And doing visual live coding, you may want to pick up your screen. Again, using GStreamer binaries, we can just capture the code or the environment into a video texture and display that and draw on top of it. Of course, because it's just a texture, we could perhaps just have a flying interface instead, which is always good to see flying code. My notes here say, if time, start flying, which is a bit odd. So we also have the ability to, say, interact with a component with the mouse. So I'll see how well I can draw JDD in freeform with the mouse. Not very well. Okay, that just about says it, yep. So we have the ability to interact within a code and pick up, say, mouse information. But it's kind of more interesting if we can interact from the code from outside. So to do this, we might add a field here. Let's say equals 0.2. Where are we? Scale. A time when your fields and your methods have the same name. But you'll see here we can then immediately start changing values. However, changing them in the code itself is not so interesting. So by, say, annotating a variable here, it disappears, because up here we now have a property that we can start interacting that from outside. Oops. So 0, max equals 2. Oops. Or we can give it a range, and we've now got a slider to interact with. If I flick back to the video patch, you'll now see that we've got a visual port that we can connect things to. Now, contrived example. Busy doing this and trying to hit a slider is not that easy. So once we have this port, we can connect other things to it. We may animate it. We may create a UI for it. We might talk to it by Open System Control or by MIDI. One other thing, Praxis Live, obviously you can work with any Java library. But one thing that comes in out of the box is support for Tinkerforge components. So they're open source hardware from Germany. Provides access to sensors and motor controllers, servos, etc. So here I've got a second graph running at the moment. Well, not actually running, start it up. So here, for anyone who can't see this bit's magic. This is an infrared sensor. See, we're picking up there the distance of my hand here, and we'll scale that down. And using variable browser, we can now find the variable we added, and now we have the ability to control things and quite easily build things that we can control in real time. Obviously, this is potentially more interesting if you're working with a Pi and some sensors creating an IoT device, but yeah, it's kind of fun to play with. One quick example. So earlier I showed you a Faro example that was on screen of them live coding some visuals. I found that last week while I was looking for some examples for this talk. And I thought I'd see how easy it was to recreate this. So here we have, let's just zoom that in a bit. So again, something we can play around with. Maybe we'll do something. Yeah, and we can start making some interesting visualizations. That's kind of interesting. We'll do that. So we can quickly and easily build up simple geometric things that kind of look interesting. I don't know how useful they are, but they're fun to play with. So that was taken from one of the Faro examples. Then I had the feeling I wanted to try this in 3D as well. So here we have a three-dimensional version of the same thing. So we're just rotating this around. And again, we can easily change the primitives that are in use. Oops, or not. Let's try that. So you can see some potential in this, perhaps for doing things like data visualization as well as just some eye candy for people to watch. So one final quick example in this bit. Where are we? We're getting towards the bit where I attempt to wake you all up, by the way. So as well as doing visualization, we can do audio. So here we have basically a setup of some sample players, a couple of synthesizers, and I think this says live coder, but it's basically a little placeholder. You'll notice we're feeding a clock signal into this. So most of the changes we've made so far have been almost immediately instantaneous. So we might have been working with time and doing things around sine waves to get things to move. But sometimes when the point of live coding is to do it with time. You want something to happen at a point in time. So here we're feeding this live coding section with a clock. This gives us a beat. So zoom this in. So we get a trigger component. Now we have a very simple form. It's called linkables. It's kind of like a reactive stream, but it's a little bit simpler. Let's try. So I mod 4 equals So that gives us the start of a building block, but it's yeah, that particular API is a good thing to use generally, but is not necessarily so quick and easy to put together when you're trying to play something immediately. So in this particular component, I just built up some simple forms that use these clocks and filters, do various things around indices and things. And then we can instead do something like so we've got a sometimes which says maybe do this. Okay, cheating time. Let's turn this down a little bit so I can talk to you. So obviously we've got the ability to work in sequence notes and things. But what's interesting then about using Java for this is that we can then actually have the entire synthesis engine written in Java. So here we've got a simple form of phase modulation synthesizer. So we have two oscillators that are changing the phase of each other. And the particular lambda here is running 48,000 times a second. How am I doing? So I can, if I wish, change the sound of this. Okay, a little bit of music. Okay, we're starting to wake up. So let's just close this for later. Okay, so that was a quick demo. We'll get back to some more music in a second. Firstly, the technical stuff. So we'll wake you up again in a few minutes. So how is Praxis Live doing this? So we have an environment basically around a forest of actors. So it's a take on the actor model, which you may know from, say, Akka or from Erlang, which again is a language that supports hot code reloading. So we have a series of components in a graph like such. Each of those components can talk to each other through the cables we drew. Now, this graph is completely single-threaded and completely lock-free. So if you're working with an audio signal or video signal where you've got a very definite deadline to meet, it's quite important that that signal does not hit a lock. At which point you're probably saying to me, that's not the actor model. Whoops. But what we've got is the ability to then run multiple graphs of things. So in a standard actor model, you may have a mailbox in each actor. Where Praxis differs in that is that rather than having a mailbox in each actor, we have a mailbox in the root of any particular graph that distributes messages when they're required. And then we have a whole load of other things that you don't see, which are services that use the same model. So the compiler in the background, resource loading for doing images or video. And then because of this model, it's very easy to then split that into multiple processes. So actually, I'm not using one process here. In the demos I've been doing, I'm using 3. I've split the video into 1. I've split the audio into 1. Particularly doing low latency audio, garbage collection is still an issue. So this allows, particularly Java-C or the NetBeans IDE code completion does create a lot of garbage. So by splitting the processes up, we can get good performance where it needs to be. So this is when I was first coding the distributed hubs. And so we have one laptop coding something on another. This is more fun, actually, when you're coding audio that's running on a Raspberry Pi or something. And in terms of the code, so we have Java-C is actually embedded, a slightly forked version of Java-C as a library. All the components, which are the individual actors, accept code as a string, which is quite useful because you can then send metacode. Basically, you can send a code string from one component to another one to rewrite it. What you're writing is actually a class body, and nothing is ever an actual file. Everything, source and bytecode, happens in memory. And it uses a class loader for every iteration of the code. So it's not using something like hotswap or JShell. And the reason behind that is that it fails fast. So if you happen to forget to initialize something, you're playing with hotswap, and you delete the line that initializes a variable, and then you run it about 2 days later and go, that just broke. So the idea is that the state is managed elsewhere, and if you make a mistake in the code, you will see the change absolutely immediately, or the problem immediately. So one of the issues normally with doing this sort of thing is Java object is behavior, state, and identity. And so we kind of split that into 3 things. So the component is what is always in the graph. That is our identity. Code context is something that kind of embodies our state. And the code delegate is actually the code that the user is writing. So the annotations within the user's code tell it what format that data is, but the state is actually managed elsewhere. Code connector is just something that reflects on the delegate and sets up the context. So the code context knows immediately when it's injected what it has to do to change the recipe from the previous iteration to this one, so we can get an immediate change. So is this abandoning our object-oriented roots? I found this quote I found quite interesting last week while looking at Smalltalk. Particularly a language that also had influenced the actor model and also had lambdas a long time before Java. Maybe we're not abandoning OOP after all, we're embracing it. So, amen, mother function. This is the performance I've been taking out various places recently. And it's a single live-coded Java lambda. So we're using that ability to work at a purely sample level. So let's. So what we have is a lambda with some setup. We have basically an array of variables, samples, which are our breakbeat, and a little bit of maths. Hope you are good at ternary operators. Oops. Thank you. So I hope you're all awake now and ready for a second day of JDD. If you're interested to tool in Praxis Live, it's all open source. It's on GitHub. Come get involved. Let's see what we can make with it. Thank you very much.